This is going to be a solve of the round of 64 PM session, Seamstress Fast. This is the case I actually went out on. However, on a second go through, I do actually really enjoy this case. So let's do the bonuses first. I like the fact that the bonuses here are all kind of separate from the case. It's almost like another mini case in itself, which is quite cool. So we have these strings here, with each letter being worth a certain value, and the value of the letters all needs to be multiplied by this multiplier. However, the multiplier comes from the previous letter. So I'm going to say let L be split text of this. That just breaks things down into letters, as you can see. So I'm going to say points is xlookup L in here, and I'm going to concatenate that with a blank string, because if there's numbers in there, they're going to come out as text. Yeah, there's numbers in here formatted as numbers, so I need to make sure they're the same format. So I'm going to look it up in there and return the bead value. So let's just show you what that looks like for a second. So that's the points. So then let's pull out the multiplier. So that's going to be, we'll call it M for multiplier. It's going to be xlookup our letters in here, and blank again, and return the multiplier. So that M is giving me all the multiplier, but because I want to shift it down by 1, I need to use one of my lambdas on this, which is shift array. Whoops, it's called array shift. So I want to array shift that by 1 row, and what you'll see that moves this array down in its entirety, but keeps it the same size. So it basically drops the bottom one off and adds 1 to the top, and I can choose what that fill is. So I'm going to choose the fill to be 1, because in the instructions the first bead should be multiplied by 1. So now we have P times M points times the multiplier. That's all of our points. However, there's a couple more points to add on, and that is if any of these things appear in this string, you need to add the points there. So I have a count occurrence lambda, so count occurrence of all these things in that. That's going to tell me how many times they're there. So I can use that to say, let's call it S for special or something like that. It's going to be count occurrences of these things in our string, and let's just lock those, multiplied by the extra value. And then my final total value of the anklets basically going to be the sum of points times the multiplier plus the sum of S, and that should give me the anklet value for anklet 1. I should be able to drag that down and get the value for all of the anklets. So 297 is the value of anklet 1, 297, and now all the bonuses are basically going to be done. How many times does 1987 appear across all the anklets? So we can say count occurrences of this 1987 in concatenate all of these. It's 3. Which anklet number has the highest anklet value? So I have a biggest lambda, which is basically an xlookup with the exact match for next smaller item. So the biggest one in there, and return there. It's number 27. What is the sum of all anklet values? That's going to be the sum of these. And then a slightly harder one, you're given a set of 7 beads. It's basically all the letters in Seamstress Fast. So let's just pull those out. So there's 7 letters there. We can choose 6 of them. So let's just say text split that on the comma for now. We can choose 6 of them, and we want to make the highest value anklet we can. So we can say combinations. This is quite a lambda heavy case actually. That thing I want to pick 6, so that gives me all of the possible combinations. Curious how many there are. 5040, it's not too many. So we can say by row concat. That gives us all of our possible strings. So if we just actually put that underneath here and then pull this down, we will have all of our values, and the max of those is 116, so 116. Okay, now we're done with anklets and into the actual case. So we have this tour information here, concert numbers, cities, so on and so on. And the first question is just what's the sum of all the concert numbers in the city? So that's a simple sum ifs concert numbers if the city is the city listed. And then next up we need to find the price for 10 tickets. However, there's a multiplier, which is explained here. You have 2 multipliers, one for the day of the week and one for the count of the concert. So I'm going to add those multipliers as columns into here. There was quite a lot of space added there. So let's do day multiplier, I'll call it DM. Let's just put those all in the right place. And it basically tells us what the multiplier is going to be here. So all we need to do is pick out the day from these date characteristics. However, the months are listed as actual month names instead of numbers. So let's just write January there and pull down to December. And let's say equals sequence of 12. So now what we can do is we can say equals date of, here's the year. The month is going to be X, look up our month name in here and return the number. And our day is going to be this day. So now we have a date there. And we can find the weekday by doing the weekday formula around that. So that is going to give me a 6. So that will be the 6th date down here. So let's just put a sequence of 7. So that is going to be a Friday, so a 1.1 multiplier. So I can just say index actually this on the weekday, and that's going to be my multiplier. So I don't actually need this. Now our concert count multiplier is however many concerts happen in a given city. So Glendale, there's 2 concerts. So the first one gets number 1, the next one gets assigned number 2. And then we go on to Las Vegas, so concert 3 is labeled 1, concert 4. So basically all I want to do is say count if this says this city and lock the top one. And that's going to give me a running count of concerts. So I can say X lookup that in our city concert number, give me multiplier. Could have actually done an index again there, but fine, I'll leave it as an X lookup. Let's now times them by each other to get the total multiplier. And that's a fair bit of work, but we should now be able to do the question. So we can say X lookup concert 3 in our concerts, get the multiplier, and we want to times that by 2,500 for a ticket price times 10, so we'll just add another 0 on the end, and that should be our answer. So in the real case I got to here fairly easily, didn't try the bonuses, and then I spent 15 minutes on this level 3, in which row of its tier is the given seat. So my basic interpretation of this was on which row of its tier is the given seat. So I'm looking at Excel rows, and it doesn't make sense to me that on which row of its tier is the given seat. And then this floor bit is very confusing. It says in the floor number, in the floor tier, the row number should be assigned based on the number of seats between you and the closest point of the stage. Well, that would be if you were here, there'd be 1 seat between you and the closest point of the stage. So is this then number 1 or number 2? But all it means is to basically label the rows like theatre rows. So it's quite simple actually. And this is a cool question to show off the power of my map lambda, I guess. So I'm just going to copy those into here. It also wasn't clear to me on the day whether you could sit in the floor tier, but on a second review some of these cells are in the floor, which means that you can actually sit there. So I'm going to label that 0 just so it's a number. Then I have a nice robot command where I can copy something, and then I can say paste values over similar background colours. So that will paste it all to here. So now I have the tier numbers labelled nicely, and actually under here is the stage numbers. If I just put that a different colour so you can see it, these are all labelled stage. So just reading ahead to the next questions, we kind of want to know what row number. We want to know distance, which is just going to be how many steps is it until you reach somewhere on the stage. So let's build both of those out quickly now. So I'm just going to format that. So I'm going to label this map first of all, just to make things a little quicker. And then let's start with normal distance. So that's just maze of map. And my start, I'm actually going to start at everywhere where there is a stage. So I'm going to say find in map, because my maze lambdas will accept multiple start and end locations. So find in the map stage. What that find in map does is just spill all of the cell addresses where stage exists. And then my allow map is going to be map not equal to blank, so I can walk anywhere essentially. What you'll see is that just spills kind of the normal steps from anywhere to get to the stage. So I'm going to set up a little table here, which is going to be to call address of cells here. Then I'm going to say equals to call this. So this is my distances. Let's make sure we line it up. I'm going to copy these. I'm going to copy these fully as values. So this is distance cell. Let's also do tier, which is going to be to call of the map. And then we want to get our distances going 1, 2, 3, 4, and then resetting here to be 1, 2, 3, 4. So to spill the actual rows, I'm going to change this to my maze distance lambda, which is a little bit more complicated. So everything's going to be basically the same up to there. The way this works is it basically takes the numbers in the cell as the distance to the next place. So all these 2's, you'll see it goes 7, 9, that would be 11, 13. So on this lambda, I actually have an argument at the end called maze lam. I have it set up to autocorrect, but it seems to not be doing it now. But basically it's lambda from to distance so far, step so far, and C. And those all represent the cell address I've come from, cell address I've come to, distance so far, step so far, and what's contained in the cell that I'm going to. And then I can use these things to say what the distance is. So if I just said 1, for example, it's going to have the distance as always being 1. So I'm going to amend that 1 to have some conditions based on the tier numbers that kind of give me what I want here. In reality, it's probably quicker to do this question manually, but this is a good example of this maze lambda. So I'm actually going to say let from, I'm going to say tier from be address to contents of from on map, and C is what's in the map for where we're going. Let's do some rules. So I'm going to say if what's in the map, that's C for what's in the cell. If C is bigger than tier from, i.e. we're moving up a tier, then we want to reset the distance. So in that case it's going to be minus D to clear the distance to 0. D is the distance accumulated so far, and plus 1. So that's our first option. Our second option is if we're in the same tier, so we're in from tier 1 going to tier 1. So we'll say C equals tier from, then the distance we need to add is 1. Then if we're going down a tier, I'm just going to put a big distance there so that it would never be shorter than an alternative route. I need another if here, so I missed a bracket. So hopefully that gives me something. So that's giving me all of them correct here, other than the floor, I think. So yeah, my floor is falling into this other 100 calculation, because for the floor, the tier from is 0. So the cell I'm going to, it is not greater than 0 if I'm already in the floor. The cell from here is the stage, and C is 0. So an easy way to fix this is actually just to change all the stage cells to a -1, so then the logic is consistent. So let's do stage to a -1 there, replace all, and then we'll also need to replace the stage here to be a -1. And you can see that just fixes everything, so we have 1 to 4, 1 to 5, and so on. So let's now do 2col of this, and that is going to be our row. I'm going to copy all this as values, so we have a pretty good mapping now. So that was a lot of setup work for question 3, but that setup should help us with the rest of the case. So for this one, we're just going to XLOOKUP our seat in stadium. Here's the cell address, and we want the row. Then for level 4, we want the distance. So again, it's the same thing. XLOOKUP the seat in here, give me the distance, but we actually need to times it by 3. That's just an instruction in the question that the distance needs to be times by 3 to get it into feet. Question 5 is a little more tricky here. What is the height of the given seat? So the height is dependent on the tier the seat is in and the row the seat is in, and actually the concert. So let's just pull these things out. Let's say XLOOKUP the seat in here, and let's pull the distance, tier, and row. It's actually going to be easier to times all these distances by 3 now, I think, so I don't need to mess around with it here. Equals this times 3. And let's copy that as values into there, and I'll need to just quickly amend this question to remove the times 3 at the end. I'm just thinking ahead, it's going to be a bit easier here. So that is distance, tier, and row. And then the calculation here is actually a little tricky because it's based on the concert as well. So we're going to say XLOOKUP the concert number in the tallest and give us the extra height between tiers. So if we're on tier 2, we're basically going to go from the floor to tier 1, gives us 11 feet, and then again to tier 2 gives us another 11 feet, so that's 22. And then each seat here is like 1 foot higher than the others. So we're in the example, we're in tier 2, so we need to add 5 feet for how many seats are here. And because we're in the second row, I think we're actually over here somewhere, N2, we need to add 1 more foot. So it's like 11 times 2, which you see in this example, 5 feet for all of them in tier 1 and 2 feet there. So it's a tricky calculation. So the way I'm going to handle it is I'm going to say how many feet up are we so far from the 1 foot in each thing. So when we're on the first tier, we start at 0. And then when we're on the second tier, we start at 5 because we've already gone 5 feet from these seats being 1 feet apart. So by the time we even get to tier 2, we're 5 feet up. Then we need to add 4 to that, so we're on 9. Then another 4 takes us to 13, and then there's 3 that takes us to 16. So this is like the base starting heights. So let's just put that into here. Base equals X lookup the tier in here, give me here. If it's not there, give me 0 because we're on the floor. So let's make this go out a little bit further. So we'll take that to P instead of B. So this is the base height. So our calculation is basically going to be our base height plus the row number we're in, plus 11 for the number of feet between tiers times the tier we're in. So that gives us 29, which matches the example. And that should track down for everything quite nicely. However, there's one tricky bit, and that is that some of these are in tier 0, in fact only 1, and in that case it doesn't matter what floor you are in because all these are sat on the floor. There's not a 1 foot gap of height between each seat. So if I put these answers in, you'll see that that is wrong, which is a little sneaky, but there's in fact one more rule that we need to put in for later as well, because this logic needs to carry over, and that rule is if the tier equals 0, then the height is 0, otherwise it's what we had before. So that will fix that logic. So this is then a 0. So for level 6, let's pull this logic down. I'm actually going to pull the headers as well, because otherwise it gets a little confusing. So this is the height, and that's the distance. So our calculation for ticket price is just going to be 2,500 minus 15 times the distance minus 10 times the seat's height. And then we need to multiply that whole thing by the pesky cost multiplier. So X lookup constant number in here, give us our multiplier, and that's how we get the right answer. And we need to round it, so I will use my robot command that rounds everything to 0. So the final question is to do that en masse for all seats. So really I want this final calculation of price to be in a single cell driven off 2 inputs, concert number and seat number, and then I can map that through all seat numbers. So this should be a good candidate for robot. So if I do, if I mark those as input cells, and without robot this stuff would basically take a while. All I'd need to do is make a let and push all of these steps into a let and then turn it into like a lambda. But let's do it with robot because it's much quicker. So we can say generate lambda statement for that. And our input 1 is in G, so that's the concert number, so I'm just going to rename that to concert. And then this should be our seat. And then let's save that lambda as. We'll call it ticket price. And now there's one more tricky thing, and that's that concert numbers only have a certain number of tiers. So concert 1 only has 3 tiers, for example. So let's just say filter our cells where the tiers, let's lock that, so where the tiers are less than or equal to, and then X lookup our concert number in tours and give us the stadium tiers. What you see there is we then get all the seats for that concert. So we want to say map across that array, lambda A, and then we want to do ticket price of this is the concert number and our seats are all of those. So if this goes well, that should give us all of the prices. I have one issue though, and that's I rounded in this calculation here to 0, so I don't want to round until the very end. So I don't often edit lambdas, but this is a good demonstration. I think if I just type ticket price, and then I do edit lambda statement, I should be able to just edit that lambda directly, yes. And then I think I can just remove this round. So round, comma, 0. So if I remove that, I've entered too few arguments. Probably because I need to get rid of that bracket. Yeah, and then hopefully if I save lambda, that works and it doesn't round it. One thing I'd like to know how to do in Robot is how to, like where I edited there, let's say I made an error, how to change some of the inputs to edit it, because when you go edit lambda, you've got all these steps. I don't really want to change the steps in the formula bar, I just want to change some of this to redo it, but anyway, that's for another topic. So now I have all of the concept prices, so I can just sum those up, and then we get our price, and we just need to round that to 0 decimal places. And that is it. So it's a shame I didn't do well on this one on the day and went out. Question 3 just confused me. It's but yeah, it was nice to have a case where I can actually show off the customization, power of this maze lambda. I feel like it can do most step type mazes. So yeah, that's that. I hope you enjoyed.